Have you ever dug a hole at the beach trying to reach the water? Or maybe planted a tree in your backyard? We interact with the very top layer of our planet all the time. But what if I told you that everything we know, every mountain we've climbed, every ocean we've sailed is just a paper-thin skin on a gigantic, mysterious world beneath our feet? Today we're going beyond the crust in our deepest dive, yet into the heart of our planet. Think about the Earth. It's a sphere with a radius of about 6,371 kilometers. That's over 3,950 miles from the surface to the center. Now consider the deepest hole ever drilled by humans, the famous Kola Superdeep Borehole in Russia. After decades of work, it reached an incredible depth of 12,262 meters. That's 12.2 kilometers, or about 7.6 miles. On a global scale, if the Earth were the size of an apple, we haven't even broken through the skin. It really puts our human endeavors into perspective, doesn't it? We've sent probes to the edge of the solar system, but we've barely scratched the surface of the world we live on. So why is it so ridiculously hard to drill deep into the Earth? The challenges are, quite literally, monumental. As you go deeper, two things increase dramatically: temperature and pressure. At the bottom of the Kola borehole, the temperature was a scorching 180 degrees Celsius, or 356 degrees Fahrenheit. That's almost double the boiling point of water. At that temperature, the rock itself behaves less like a solid and more like plastic, making drilling incredibly difficult. The drill bits would overheat, and the hole would constantly threaten to collapse. This extreme heat was actually a surprise to the scientists. It was much hotter than their models predicted, and it was the main reason they had to stop drilling. The pressure is just as insane. Imagine the weight of a 12-kilometer-tall column of solid rock pressing down on you. At that depth, the pressure is about 4,000 times greater than the atmospheric pressure we experience at sea level. This immense pressure can crush even the most robust equipment. Designing drill bits and pipes that can withstand this environment is a massive engineering feat. The rock is so compacted that it's a constant battle to grind through it. This is why projects like the Kola borehole are more like scientific expeditions than commercial drilling. The goal isn't to extract anything, but simply to see what's down there. And what they found was truly astonishing. The Kola borehole was a treasure trove of scientific discoveries. For starters, they expected to find a transition from granite to a denser rock called basalt at around 7 kilometers deep, a feature known as the Conrad discontinuity. But they never found it. The granite just kept going. This completely changed our understanding of the continental crust's composition. Even more exciting was the discovery of water deep within the crust. Scientists previously thought that deep rock would be bone dry, but they found water that was likely squeezed out of rock crystals by the immense pressure. It was trapped down there for millions, maybe billions of years. Perhaps the most mind-blowing discovery was evidence of microscopic life. Deep within the rock, they found the fossilized remains of 24 species of ancient single-celled organisms, perfectly preserved. These microfossils were over 2 billion years old. This suggests that simple life could exist or did exist in conditions we once thought were completely inhospitable. It opens up a whole new window for where we might look for life, not just on Earth, but on other planets as well. These weren't living microbes, but their presence proves that the deep Earth once supported a biosphere. So, if the Kola borehole stopped because of the heat, are we just stuck? Not necessarily. The spirit of exploration is relentless. New projects are being conceptualized all the time. For instance, scientists in Japan are working on the Chikyu project, which aims to drill through the oceanic crust. Why the ocean? Well, the oceanic crust is much thinner than the continental crust, only about 6 to 7 kilometers thick, compared to the 30 to 50 kilometers of continental crust. By drilling from a ship in the middle of the ocean, they hope to be the first to actually penetrate the crust and reach the next layer of the Earth, the mantle. Reaching the mantle would be a game-changer for geoscience. The mantle makes up about 84% of Earth's volume. It's a vast, slowly churning layer of silicate rock that drives plate tectonics, causes earthquakes, and creates volcanoes. Getting a direct sample from the mantle would be like finding the Rosetta Stone for geology. It would give us unprecedented insights into the chemical composition of our planet's interior and the processes that shape our world. The technology for this is even more advanced. requiring a ship that can stay perfectly positioned over a single spot for months or years while drilling through miles of water and then miles of rock. Let's journey even deeper into the theoretical. Beyond the mantle lies the Earth's core, separated into a liquid outer core and a solid inner core. The outer core is a swirling ocean of molten iron and nickel, and its movement generates Earth's magnetic field. This magnetic field is our planet's invisible shield, protecting us from harmful solar radiation. Without it, life on Earth would be impossible. The temperature here is estimated to be between 4,000 and 5,000 degrees Celsius, as hot as the surface of the sun. The pressure is millions of times that at the surface. Drilling here is pure science fiction. And then, at the very center, is the inner core. It's a solid ball of iron and nickel, despite being even hotter than the outer core, reaching up to 6,000 degrees Celsius. Why is it solid? The pressure is so immense, over 3.6 million times atmospheric pressure, that it forces the atoms into a solid crystalline structure, even at those incredible temperatures. Recent studies even suggest the inner core might have its own inner core, a distinct region at its very heart. We see these layers not by drilling, but by studying seismic waves from earthquakes as they travel through the planet, changing speed and direction as they pass through different materials. It's like giving the Earth an ultrasound. From the thin crust we call home to the solid superheated core, the Earth is a planet of layers, each with its own secrets and extreme conditions. Our attempts to drill deep are a testament to human curiosity and ingenuity, pushing the limits of technology to peel back those layers. The Kola Superdeep Borehole wasn't a failure for stopping. It was a resounding success that rewrote textbooks and showed us just how much more there is to learn. The quest to drill deeper continues, promising to unlock more mysteries about the very ground beneath our feet. The Earth's interior is the last great frontier on our own planet, and the journey to its heart has only just begun. Thank you so much for joining me on this deep dive into our planet. It's incredible to think about the world that exists right under us. If you found this journey as fascinating as I did, please hit that like button and consider subscribing for more adventures into the wonders of our universe. Let me know in the comments what other deep topics you'd like to explore. Thanks for watching and see you next time.